All right. Get rid of this stuff on my screen. You can see my screen all right?
Yeah.
All right. No, I just wanted to do a topic that it came up in the last couple weeks in a few different places. 2-wire Bacnet versus 3-wire, so I figured I'd put some slides together at least to get us thinking about it, to discuss, I guess, the way everybody does their Bacnet wiring in the field and, what they see, what they hear, issues, that kind of stuff. But I was breaking down Honeywell, Johnson, and EasyIO. And I picked those three because, one does 2-wire, one does 3-wire, the other one does some of both and is heading towards all 3-wire. So I try to pull some resources together, at least to then use this slide as a resource document that you'll be able to pull off of BP Tech Center when we get done. Plus the recording will be on there as well. So if you have any questions along the way or comments, please speak up. I started with pulling out of the Honeywell Spyder training slides that Hutchie had done a few years ago. But the first one I wanted to show was what the actual Bacnet spec calls for. That was created, I guess, through Asher, I think, created it originally. But they call it a EIA 485 network. And the nominal impedance of the cable would be between 100 and 130 ohms. And then it goes through about the distributed capacitance, and typically it's a low capacitance cable with 100 to 130 ohm impedance. Shielding is typically, I've actually found documents where they question whether shielding is even required, but part of the requirement in the spec is that shielding be used. Not typically, pretty much all the time, shielding should be done where it's only grounded at one end, and it's a continuous run from controller to controller. If there's no shield terminal on a controller, then you just tie them together and save them off, and just so that you have a continuous run from the first controller down to the last. A lot of controllers, including the Spyder controllers, have the shield terminal, which is electrically isolated. It's just there as a convenience point to land your shield wire.
It's not connected internally to anything.
Nothing at all. Yep. And you start getting into bus terminations, and a typical RS-485 network, usually you'll hear that it's 120 ohm resistor that you use, double terminated, one on each end. And that's because typically the wire type is 120 ohm impedance. So you match the impedance of your cable with the resistors that you're using on for your end of line termination. Now Johnson Controls, they do their bus termination a little differently. One, they have switches on most of their controllers to enable end of line. And if the end of line device does not have that, they actually have a termination module that you use to terminate the bus. And rather than just having a resistor across your plus and minus, it's actually an active device. It takes 24 volts AC, and then you're actually wiring it to plus, minus, and their third wire, the reference, the signal reference termination point. And then if it's a 2-wire device, then that third wire, the reference one, the blue, you actually safe off and don't use it, which is what's shown in the diagram on the right side there. They say it provides better performance for an MSTP bus using their end-of-line termination device. Actually, I haven't physically seen one of these, and I've never actually used one. I don't know if
they're like $120.
Oh, they're expensive. Okay. Compared to a resistor.
Right.
But pretty much every other vendor I've seen for not for MSTP, just RS-485 in general, Modbus or MSTP, it's 120 ohm.
Right.
110, 120 ohm, depending on the wire.
50-cent resistor.
Right. And part of that is you really don't want to mix wire types either on your network run. You mix wire types and you end up running into other noise issues and reflections and things like that. and I physically have seen that years ago on a C-bus job. 50 feet was they used a different wire, because they used existing wire there, and the rest of the network was one type. In this one section, they couldn't pull new wire. They used that, and they had nothing but problems. They got a 500-foot spool of wire and went around the hall on both ends to test it. Problem went away. So all of a sudden, they found a way to run the wire, and they took care of it, and it worked. But you really don't want to start mixing wire types, manufacturer, or even just different types of wire from the same manufacturer.
The capacitance of the cable messes with the signal?
Basically, yeah. Be the impedance as well, you know. Some of the other things you'll hear, typically you only hear about the unit loads is when you're working with the Spyders, because Honeywell publishes that information where others really don't. You hear on a MSTP network, you have a maximum of 32 devices. And really what it comes down to, it's a maximum of 32 unit loads. And a device can be rated for different types of unit loads. It could be an eighth of a load, a quarter, one load, a half. Spyders are a quarter load. Struggled trying to pull information out for Johnson Controls, but I did find a document that said, figure that PCG, PCA is one unit load. Yet if you read another document, it says if it's a network of only Johnson Controls PC series controllers, they are, I want to say it was a quarter or a half, but they basically are saying if you stick with just their controllers, you can add more devices. But I still think it's safer if you do 32, stay within that 32 devices.
If you know what the unit.
If you don't, especially if you're mixing controllers from different manufacturers, you're integrating with other things, your best bet is just to stay at the 31. You figure the JACE would be one and then 31 other loads. You could add repeaters to the network to extend the network length or quantity. And part of that, the reason I'd shown that was with the Honeywell Spyders, they recommend, I'm not sure the right way to say it, is the biasing network added to the MSTP network. And that's a resistive device that actually is, I guess, more like what the Johnson thing does, but that's just end of line. But for this one, it's got a voltage through
the voltage to hold it high.
And then resistance between the plus, the minus, and the common. It's something that's provided by the JACE has jumpers to enable it. On the 8000, you have switches to enable it. Third-party routers like the contemporary controls router, they have it built in. But the thing you got to watch for is that biasing actually takes up 20 to 22 unit loads of a network. So of your 32 unit loads available, it uses up 20 of those.
Choke down your network.
So if you look at like a Spyder quarter load, you could do, 48? You could do 48 devices electrically because of this unit load thing. If you have a bias, you got 20 unit loads used there. So if you go 48, that ends up being, 12 unit loads. That gets you to your 32. But you're not going to go nearly that length if you're going to add somebody else's controllers on there as well. Now, the thing I'm hoping we'll get a discussion going on is this whole 3-wire 485 network versus a 2-wire. And I summarized on there, Honeywell Spyders and Strikers are 2-wire. They have a plus and a minus on the controller, and their documentation, they always refer to a twisted pair, shielded. The Johnson Controls series controllers are all 3-wire. They do a plus, a minus, and a signal reference, common.
Like N2.
And N2 is the same way, right. And then EasyIO, their FG20 and 30 series controllers are 2-wire. The older FS32s were 2-wire, and they're now 3-wire, and the FW series controllers are a 3-wire Bacnet MSTP.
Notice that the FG and the FS, the only difference besides the resources is the 3-wire RS-45 terminations.
Right. And then, like, I have a slide for it, but on EasyIO, they're a 3-wire plus, minus, and S. S is signal common, not shield.
That's confusing.
So on Spyder controllers, because it's two-wire, you have really, RS-45 is a three-wire standard. Their transceivers all use, it's a plus and minus, and then you have a reference, which is it actually measures the voltage difference between plus and reference and minus and reference. So on a two-wire device like a Spyder controller, you still need that third reference line. And what they've done and what many manufacturers do is they use the earth ground as your third common. So it's important on a Spyder that you do that jumper between 24 common and earth ground, and that every controller is tied to earth ground. Now, where you can run into issues if you have a bad earth ground and you're running your network across the building, and you have different voltage differences out there that could cause some problems. But you really need to make sure that you have the common, the 24 volts jumper. In actuality, that 24 common is also common to all of the universal inputs and output commons as well.
Hey Frank, is that why they went? Can I ask a question? Is that why the EasyIO FG32s went from they went from a two-wire Bacnet on an ungrounded controller to a three-wire Bacnet?
On the FS controllers and the FW, yes. The FGs are still two-wire.
Right, but they don't have a ground either. So how do they? I
have a slide for it, but basically you have to tie. They recommend a three-wire cable, and the third wire you tie to your universal input or output common throughout. It's interesting because on their documentation, their installation instructions, they talk about twisted pair for your 485. Yet if you go to the Bacnet manual, the very last page, they have a paragraph there that they recommend three-wire and use that, like I said, the universal input or output common as your termination point for that third common wire.
Huh.
So like here on a Spyder, you have net 1, net 2 are your, well, really it's your plus and your minus would be your Bacnet, and then you have your 24 common and earth ground. Actually, from the factory, there's a jumper in there. Right. But many times that falls out. You have the thing mounted and somebody unscrews, loosens a terminal, put wire under it, that thing falls right out and you may not even notice it. But in many cases, the communication issues on a Spyder is the fact that they don't have a good earth ground, or they don't have that jumper between 24 common and earth ground. In the Johnson Controls FX world, or Metasys world, whichever, they have a three-wire plus shield. So you got a plus, minus, and a common. So the common terminal, that's your signal reference for your controller, for the MSTP communications. And they have a place to be able to land the shield just to make it easier to terminate the shield instead of just using a wire nut at the controller to have it pass, all the way through your network. And then on the FW and the FS series controllers, they have a third terminal marked S, and as I mentioned, that's actually their signal reference. They're common for the three-wire communications. On a FG controller, they only have the two-wire, so they recommend wiring the third conductor to one of the universal input or output commons. And then internally, that universal common ties back then through the transceiver. Sort of like on the Honeywell controllers, the 24 common or the universal commons are tied internally, and that's where its reference is coming from. So it's not really measuring voltage difference between plus and minus. It's always going to be between plus and your signal common, and your minus and signal common. And the reason actually where this all came about was I had a job where we had, there was let's say communication problem. Now they blew out perceived that they blew out the 485 port on an 8000. And Web Squad actually sent an email with a link to two articles from Chipkin which I included on the last slide on here with the link so that you'll be able to pull it down off of BP Tech Center to reference those documents. But those documents actually talk about using 3 wires instead of 2 wires. Now, it could very well be that they did because there's reference in there of ground loops and how you ground it and that kind of thing. But it was very obvious in this document that doing it with 3 wires, like EasyIO recommends, like in that last paragraph there, about having the 3rd wire tied to your universal common, you're going to be in better shape. Because if you think about it, if you run that wire all the way through your network, you know you have a good common reference on every controller. Where with earth ground, that may not be the case.
Yeah, how many contractors actually hook up the earth ground at their Spyder?
Because usually you ask that question when there's a problem, and they'll say, yeah, we did. And I said, well, make sure everyone is. And usually you'll find a couple that aren't. That's part of the problem. Now, the one area that a lot of times this comes up as a question is, all right, we got a Bacnet 3-wire network, and the JACE, or in the Johnson world, the FX80, or even the 600s or 300s, they're all 2-wire connections for 485. And there isn't anything in any of the documentation anywhere by Tritium or by Johnson Controls that shows this wiring and how you would do it. And I had asked Johnson Controls tech support, and they had made this document up for me about a year ago, a little less than a year ago. Started out as a napkin sketch that he scanned and sent me, and then he finally made up a document for me. But basically what they're showing there is using your 3 wires, and the S terminal on the JACE, use that as your signal common reference. So your 3rd common wire that goes to the common terminal on the controller, that lands on the S terminal. And it's just a convenience termination. It's not internally connected in the 8000, but it's a place to land that. And if you're going to use their active terminator, it would land on that same terminal. At that point, you don't ground that S terminal, and you leave the shield separate from the JACE, and again, earth ground at one end or the other. So you're basically taking that 3-wire network, and you're really only terminating 2, and it's just you're landing that common right there at that controller, or at the JACE itself. And you'll notice they also have you set the biasing switch on the JACE to mid, so you're not adding any biasing, nor are you adding any end of line to it. So that's what the recommended way to terminate a 3-wire Bacnet bus to a JACE. And realistically, that would be a similar thing as if you were mixing a Johnson controller with somebody else's 2-wire controller. You still want to have that common work your way through, but you're not tied really at the controller that's only 2-wire. And these are some notes from those documents I listed at the bottom there that Web Squad had sent me on that one job that had the problem with the ground loop. But they talk about, that the RS-45 is a 3-conductor network, and the 3rd wire is your common reference signal, and as I mentioned, the Spyder uses earth ground for that. So you could actually pull away from that and not jumper your 24 common, I guess, and use a 3rd wire and bring it in. You may have better communications with that. I did email Web Squad back to get their viewpoint on what they sent me is, do they recommend us using 3-wire or 2-wire? Unfortunately, I didn't send that to Mike until yesterday afternoon, so I didn't get a chance to get anything back from him. But it'll be interesting to see what they actually come back with. I'll add that to the slide when I do hear back from them.
Well, we sell 3-wire MSTP cable, which is less expensive than the 2-wire.
Yep.
We should get them part numbers for folks too.
Right.
And we got a couple different brands, so you have to, I'm not sure which one we're stocking now, but we'll put it all in there. Yeah, I think Connect Air is the main one now. The voltage level on the TX and RX are measured relative to that reference wire, not to each other. So that's why there's that need for that third wire. As I mentioned before, roughly 120 ohm nominal impedance. And as I was reading that document, apparently some manufacturers of wire actually rate their cable not with a nominal impedance, but as an impedance per foot for the cable. And that apparently is cheaper wire, and it's not as good. So then you have to worry about how long your network length is on determining which wire is the right wire to use. Then one of the things they commented on is a risk if you don't use a third wire. You talk about blowing out 485 ports if you have a ground loop. And I know they recommend tying in that ground reference conductor before tying in the others to keep that from happening. I mean, the last thing you want to do is have a port on a JACE blowout. And realistically, we don't have a 485 port on our laptop, so we're sort of isolated and insulated by having, a Bacnet IP to 485 router, in place. So you could blow that could get blown out as well. So you just got to be careful. As long as you follow, as long as you follow the recommendations of each of the manufacturers, I think you're in good shape. But to ensure solid communications every time, I think that from what I'm reading and from what I understand, that third wire is worth putting in there. And if the cable we have, that the 3-wire cable that typically gets used on the Johnson controls with their 3-wire controllers, it's less expensive than the low impedance. We're going to have twisted pair that we
start reconditioning ourselves.
Right. Well, that's why I wanted to do this session I wanted to at least get the information from each of the manufacturers out and up front, and then discuss what everybody feels about this and what they've seen in the field and what seems to work for them. That's what my intent was with this. So I really didn't give it a whole lot of thought until that issue that came up recently, and then getting those documents from Web Squad. I think, wait a minute, they're a 2-wire device, yet they're sending me documents talking about 3-wire. So I kind of opened my eyes up to, the differences and, what the best way to go is on that. But that was the slide part of it, just to then hopefully have a discussion on this topic. Ralph, Kevin, what do you guys do? What do you think?
Well, Frank, I just finished up a job where I had multiple York rooftops with the factory Bacnet boards in them, and had 70 plus VAVs, all with Spyder controllers, and we pulled 2-wire throughout without any problems.
Right. And
I'm a little concerned I'm going into a much larger, and the reason why I'm attending this meeting now is we're 3/4 of the way through a much larger job, over 100 VAVs, double the rooftops. Again, Yorks, based on no problems before on our last job, we went ahead and roughed in the 2-wire Bacnet. And now I'm a little concerned.
Well, I mean, your success with it is, I'm sure, because you made sure that they installed it with the jumper for the 24 common, the earth ground, but you also made sure that they're all earth grounded.
Yeah,
and usually where the problem comes in, usually is when guys don't really spend any time looking at that part of it, or don't talk to their installer, their electrician, on making sure those things happen.
Okay. But you still think it's best practices going forward to use the third wire Bacnet?
From what I'm reading, it seems that way. I'll be curious now to see what Web Squad comes back with, because I asked them that pointed question of 2-wire or 3-wire, so it'd be interesting to see if they even say 3-wire, since theirs is 2.
Okay.
But I'll get that out when I do hear what their answer is. I think running the 3-wire, one, if it's less costly, Then if you only end up using the 2-wire, you're not going to, you safe off that third, you're okay.
Mm-hmm. Yep.
But you have it there in case you need it.
Yeah, most of our problems have, like you said earlier, where our techs did not take the time and ground the controller. So we've learned the hard way, and we're pretty methodical about it now. But
right. So you got quite a few devices now. How do you determine the break point on multiple networks? Multiple segments?
We try to keep each respective VAV with its rooftop, and we'll break it up, like you said, by loads. You know, if I end up having a 4-wire network coming back to a JACE, that's what we do. We'll buy the extra MSTP, but we haven't had that yet.
Right. So do you try to keep, do you look at the Spyders being a quarter load, or are you just making sure you're under 32?
I make sure I'm under 32.
Yeah, okay. That's typically, I think, been a good rule of thumb to make sure that you're not going to have any issues, because you never know when you're going to have a third-party device. And if you don't, if they don't publish,
is one load, so.
Yeah, if they don't publish it, you have to assume that.
Mm-hmm. Yep.
Otherwise, you really get yourself into trouble.
Yeah, we had another contractor a while ago, Ralph, that was, it was a Spyder network, Bacnet network. They had horrible communication problems because they had a transformer at every location, at every VAV location, and everybody hooked up to 24 volts. They thought they had their ground in place, but what they didn't check was that the hot and the ground from the transformer were polarity sensitive, and people were just hooking up 24 volts willy-nilly. They weren't paying attention. The controller powered up. It didn't care, but they were mixing the hots and the grounds from the transformers, and it was hosing up their bus. So that's something else that's something else to be real mindful of, that low side of the secondary to ground. You'll measure the high side to ground. It should be 24 volts. The low side should be around 13 to 16 volts, something in there, depending on the transformer. But folks were hooking up the hots to the common and then grounding that, and they were getting away with it because by themselves it's a non-issue. But when you hook it up to a 485 network, it messed with the communication big time.
Got it.
So something to be mindful of also on these 2-wire gigs.
And it's interesting, reading through these couple articles, one of the things they mention in there is whether or not the shield is required. And the comment is that without the shield, the plus and minus being a twisted pair do a better job of removing the noise than using the shield does. I mean, I spent close to 20 years in the branch doing RS-485, not MSTP, but doing RS-485, and it was twisted pair, 18-gauge solid, no shield. And, there's a lot of those systems are still out there running now, and it was rock solid.
Bulletproof, right.
Now, it could be a difference being that it's 18-gauge versus 22 or 24-gauge, and it's slower. The slower the baud rate, the larger the gauge wire you're using, and it was all 9600 baud, so that probably made a difference too. But like I said, I'm going to have a link for these 2 documents on that last slide. And there's a third one that I'm going to include in there as well that was put out, actually it's 2009, a guideline for installing Spyder Bacnet controllers, and it has some sections in here on an oscilloscope, on what voltages to look for and, what's a good network, what's a bad network, that type of thing. Obviously, that applies to anybody's Bacnet network, not just, Honeywell Spyders.
And in reality, who's actually hooking up an oscilloscope to their Bacnet network? Who has time for that crap? We're in a hurry. We're trying to get the job done. The only time we do that is when we have problems. And network, intermittent, especially network communications, that could be a timely, search and find out where the problem is. It could take forever. I try to tell people that when you're installing your network, don't just be jerking wire around a building. I mean, you need to take care of and be mindful of these things, and then it saves you so much more time down the road, especially with communication problems.
And keeping your wire away from loads and, things like that. I mean, I've seen some funky you know, they'd have the wire pulled and wire tied to a conduit that's got the 480 going up to the units for the compressors. And I've heard, you know, you could hear, you know, wires slap in the conduit when they, you know, the compressors turn on, and the bus would go down quite often for, you know, for a few seconds, and as far as 485 strapped to it, and that caused all kinds of problems. They, you know, you cut the straps, you move it away from the pipe, and everything's fine. So, you know, you got to be careful on, you know, there's, you know, where they pull the wire, where they tie the wire down to, you know, if it's not in conduit by itself.
Frank, did you have a slide that showed typical wiring to a Spyder using the third wire Bacnet network?
I do not, but we can.
It's the same as the EZIO, right?
Yeah, actually, it would be the same. I actually didn't have a slide for.
You're just going to bring the reference to universal input or any common on a Spyder. Every, you know, screw terminal number 2, which is your 24-volt common, low side of the transformer, is shared on every common, analog output common, universal input common, digital input common. They're all the same point. So you could bring it to any common point, you know, as long as you're not using an output common. Actually,
no,
it
output
isn't
common.
On a Spyder S, on a Spyder R, it's not.
Well, it's not considered a common at that point.
No, it's that's a switching
right.
Common, not.
So really, if you look at just the universal input and output common,
yes.
You're safe.
So you're saying just take that third wire and land it to a common of one of the universal inputs?
Yeah. And like I said, that's part of the conversation I'm having right now with Web Squad to get them to bless us doing that.
Like Greg said, you know, you're going to have to retrain yourself.
Yeah.
Yeah.
I mean, Ralph, think about it. For years, we jerked around a 2-wire or a twisted pair, and that was it. That was what we did. And now everybody's saying, hey, we should be using 3 wires. I'm like, oh boy.
Yeah. As soon as Frank said that, I went, oh God, I just finished pulling the network out through this entire building.
That's great. But I mean, that's why I figure it's better to bring it out in the open now. And
Johnson's used 3 wires forever, you know.
Yep. Yeah, because really N2 was the early form of Bacnet. I mean, and also, like I said, for years it was just a 2-wire with, you know, standard 45 stuff.
And it doesn't matter if this UI common already has, like, say, a pressure sensor or something tied to the common. You just still land that third wire right on the common without any problems, or does it have to be one that's isolated?
Yeah, because if you think about it, your 24-volt common on a Spyder is common to those commons.
Yeah, it's all internally shared.
It's all internally tied. Yeah.
It's basically a stable point that the transceiver references positive to reference and negative to reference, because ground potentials can vary from place to place. I think that's their point, right?
Yeah.
So I've got a retrofit application with an existing COM bus, and it's only a 2-wire COM bus, and I'm planning on using the FW series controller, Bacnet MSTP. Would it make sense to land the reference, just round that reference in lieu of a 3rd wire, so that at the very least everything's referencing to ground? Or should I just roll the dice with a 2-wire and skip the 3rd wire altogether?
Well, if you got the 3rd wire, you got the FW is 3-wire.
Right. I don't
they want you to use that 3rd, you know, that S terminal as your signal common.
I know.
You could do is if you use the 3-wire, you could just pass it through the 2-wire devices. So at least you have it there and not necessarily, you know, tie it. So it's really going to depend on that manufacturer and how they have how their controller is set up.
Well, it'll be, the bus, when I'm done, the bus will be just FW controllers on this existing 2-wire bus.
Okay.
And then it'll be landed on a JACE, on the 45 port of the JACE. So, you know, I could omit the 3rd terminal altogether and not do anything with it and cross my fingers and hope it works. Or while I'm in every unit, run a jumper between the S terminal of the SW and ground, just to give it, hopefully the grounds are all the same, and then they all have a solid reference. And
well, I mean, they do talk about, this is EZIO's notes that I have on this slide here, and they said connecting this to ground will cause incorrect voltage and may even damage the transceiver.
all right, there's my answer. Okay.
That's the part we got to watch out for then. If you do that with a Spyder, you need to make sure you don't have that earth ground jumper in there, I would think. But I'll get that clarification from Web Squad on the proper way of doing it.
I think they're just saying don't connect it to ground because you don't know what ground is.
Right.
That's all they're saying there.
So
They're saying it's better to use that third wire because you know what it is. It's a known.
Right.
Whereas ground is not really a known.
whereas in the Spyder world, they want everything grounded.
Right. They're assuming that ground is good. The assumption is different between the two.
Correct me if I'm wrong, but in the past when there was a third wire, wasn't it common practice versus the wire through that third wire at a Spyder? Why do I have that stuck in my head?
Yeah, so that you're saying like a shield would be. You don't have a termination point there, but you tie the common on both wires together to pass it through to the next.
Now, I had a job that was Johnson, and they wanted to go with the Honeywell for replacement controllers. Mm-hmm. And I thought the workaround on the Johnson 3-wire network is that third wire, the one that we would tie to the UI, we would just wire through the Spyder, not even connect it anywhere, just twist it together and send it to the next unit.
Right.
But now they're saying land it to the UI on a common on a UI. Or am I misunderstanding?
They're not saying anything. That's not what, no, in the Spyder side, they're not saying that at this point. They're saying the third wire is the earth ground.
Okay.
That's why I want to get clarification out of them that if we go with the 3-wire, what's the right way to then terminate that controller?
And for some reason I had in my head we just wire right through it. We don't even connect it.
That's what, in the past, that's what we would do.
Mm-hmm.
Like the shield or the
It's almost like having another shield, but you're not grounding it at one end or anything. Because realistically, if you have all Spyder controllers on that network, you could terminate that third wire to a common in that controller because that's really what the earth ground is anyway, so you're not going to hurt anything doing that.
Right.
And actually, with the way you have it, then if there was any communication issues because of the earth ground, you have it there to terminate at each controller if you really had to.
Right. Makes sense.
Any other comments or questions on that?
I'd like to learn more about biasing.
Yeah, biasing,
that's good. Can we circle back to the biasing?
Yeah, because biasing, I went digging to find any information on any other manufacturer, or I was looking in the EZIO and Johnson Controls for biasing because it's all over the Spyder stuff. And it's not referenced at all.
We did 485s for years. I never even heard of biasing until these controllers came out.
You kind of caught me off guard on that one when you said the biasing takes up 20 unit loads. That's why self-guard.
Talk about bogging down your boat.
Yeah, I mean, that's why they say, the Spyders, you could have up to 48 controllers because it's a quarter load for each Spyder. You have 32 minus the 20 that the biasing does, which leaves you 12 full loads, which would be 48 Spyders that could go on there then.
Yeah, but even the Bacnet controllers from the 90s up to present, I mean, they didn't talk about biasing.
Yeah.
Unless it was built into their transceivers or something.
But it's typically only done in one spot. And obviously, it's something that should be used because contemporary controls routers, the one's not the portable one, but the regular one, it has biasing jumpers in it. The JACEs, their 485 ports have switches or biasing jumpers to enable them. So it is something that's discussed, and actually they do talk about, I'm not sure if these two documents had it or not, but I've never had I never found any Johnson documentation that talks about doing biasing on the network.
Yeah, or Allerton, or Automated Logic, or any of these other Bacnet devices. No such thing, or they don't talk about biasing. Maybe it's, like I said, maybe it's built in, or it's not required for their network.
Right. I mean, 'cause if it's built in could be a problem then if you have multiple ones.
Mm-hmm. That would make sense. So I don't know. This is a new phenomenon for me.
Yeah, so that is definitely a gray area.
They say do it, and so we do it, and I don't know why.
Yeah, and do it for Spyders. Now, the original Bacnet Spyder classes never discussed that full load and the biasing taking up 20.
Right.
It was the more recent John Hutchie classes that actually have it in the slides. When you hear quarter load and 32, that's what, 128? That's a lot of controllers you can put on a network. That's not really the case. You really can't do it with that many. And also, I think that if you were to look at what the circuit equivalent is for that biasing switch on an 80 or an 8000, it's more. It looks to me like it's more than just biasing or end-of-line termination. It's not what I expected for end-of-line. I expected to see, just enabling a resistor across the network, and it wasn't. There was, I don't remember exactly what it was. I should get a slide added to this with it, that it was more than just that. And I found in a lot of cases if there's problems with the network, if the biasing switch is on, you just say, okay, well, if it's the end, put it to end or put it to mid and see if that helps. And I've seen that resolve a lot of issues too. Almost be better off mid and then put a resistor there if that's the end, I guess, but it all depends. But there is no clear documentation on that part of it.
It's more than I read somewhere that Ed just induces enables a resistive circuit inside the JACE and nothing special. But you've seen that's different.
Yeah. I'll do some digging on that. See what I can pull together.
Yeah, it's kind of gray there.
Yeah, absolutely. Gray, except if it's all Spyders, you use it. Because I've seen if you didn't use biasing with Spyders, it does cause problems.
Yeah, I got an 8000 in my hand right out of the box, and right from the factory, it's set at biosing on both COM ports. So I was just curious how my field techs were handling it.
Yeah. Yeah, because a lot of times, I think they probably look past that, don't even realize that's there.
I guarantee you they are. Yeah,
right.
I guarantee you they are.
Out of the box, it comes in mid position?
Yeah, I'm looking at one right now, right out of the box, Greg, and both are set at mid position default.
Which is disabled, basically.
Which is disabled, yeah.
That's not biosing?
Yeah, mid means it doesn't have anything.
It's not inducing.
No, I'm saying the switch is in the middle, which says biosing, not mid.
Oh, so it's, really?
Dead center, which is dead center. On both ports, which is labeled BIA, which I assume is BIOS.
Right. It's biased. That's right. Yeah, it is biased.
Yep.
Yeah, I mean, I think the majority of the install people, they're not touching that stuff, and they're just rolling the dice, and we circle back if there's a problem. But a lot of these buses just are, they roll with it until there's a problem.
Yeah.
And we start looking deeper. Call Frank and say the comp's not working.
gives me
Try
48.
changing this switch to another position.
Wire polarity, correct. Earth ground.
Basically, that allows 48 spiders per network.
Yep.
Less
Which
if
is
you
quite a
got
few.
to it.
That's where I think you're still safer. You stay with the 32, you're not going to have any problems.
Let's stay within the 32 unit loads, right?
Yeah.
Gotcha.
All right. Is there anything else between now and the last time? If any, does anybody have anything they want to throw out there or discuss? Or I am working with Brian Klein at EasyIO to try to get him lined up for next week or next month with the FW and Wi-Fi and setting those up. I think that would be a good topic. So we got a few jobs out there contractors are doing where I think it would be helpful. They've got some firmware changes coming up that I think they've had some issues, and I think it's worth visiting that with them. And I think it's going to, just Wi-Fi in general would be good to get more, get more information on it and understand it better. So, I guess if nobody has anything more than that, I guess we can call it a wrap for this month.
All right.
And obviously, if
Thanks for
anything
your time,
comes
guys.
up, yeah, thank you very much for your time.
Yep. Have a good morning.
All right, bye.
Yep.
Yep.